Hello friends, welcome to my YouTube channel AI Geek, and today we are going to explore more about supervised and unsupervised learning. So let's get started. Supervised and unsupervised learning are two types of machine learning, and the data structure decides whether the machine learning will be supervised or unsupervised. For supervised learning, the data structure will have some labels, and that label will have outcome, and this is the outcome which machine learning algorithm will try to predict. In unsupervised learning, the data structure will not have a label. So here machine learning will not predict anything, but it will try to identify some patterns within the data. Let's see this in the coming slides with an example. So this is the data for supervised learning. Here we see 5 columns, and this data is about automobile data. So the 5 columns are cylinder, bore, horsepower, peak RPM, and finally the price. Here the 5 columns are called features in machine learning, and we have the value of for each of the column data. For example, cylinder, we have various values like 4, 6, 5, and similarly for bore we have data like 3.47, 3.47 again, 2.68, and so on. Similarly for horsepower and peak RPM. Based on this data, the automobile has some price. So here this price column is the outcome. This is called the label, which the machine learning algorithm will try to predict. And how it will predict? It will predict based on the values of cylinder, bore, horsepower, and peak RPM. So what we assume here that the price is a dependent feature whose values depend on the value of cylinder, bore, horsepower, peak RPM. So if there is a clear correlation, machine will be able to understand that correlation and it will be able to predict that value. Now we will have a look. So now we will have a look at the algorithms for supervised learning. The first algorithm applicable is regression model, and the second model is classification model. The regression model we just saw in the previous example, that was an example of regression model. So what we do in regression model, we have one dependent feature and one is the independent feature. The dependent feature value will depend on the value of independent feature. Let's move back to the previous example. If we see here, the price is the dependent column whose value depends on the 4 features. So if for the sake of simplicity, if we take, let's look at this example in detail. So we have two axes, x-axis and y-axis. So x-axis is the height in inches and the y-axis is body weight. So here what we are trying to do is to predict the value of y-axis based on the value of x-axis. So the body weight we are trying to predict based on the value of height. Like in the previous example, we were trying to predict the automobile price based on 5 independent variables. But here for the simplicity, we have taken only one independent variable, and that is height. So we can see that if the height is increasing, body weight also increases, and there is a clear correlation. So this is the line which fits uh, the body weight and height, and if you have a value of height like 70, you can easily predict corresponding body weight to this 70, and this will be very near to the actual one. So it all will depend on how accurate is your fitting line. So this is the fitting line here. So if this fitting line is very accurate and represents the data very well, then the error will be smaller. This was a very simple case, but we may, in the real life situation, we may come across more complex cases where the line will not be a straight one. It may be a polynomial of second degree or maybe third degree also. So it all depends on the type of correlation between dependent and independent variable. And most importantly, the number of variable will not be one. Here, for simplicity, we have taken one. In real life situation, we may have more than one independent variable like we had in the previous example. Now the second algorithm which can fit for supervised learning is classification model. As we already mentioned, in supervised learning we have a label which has an outcome, and the machine learning algorithm tries to predict that. In the previous examples, the label was a numeric value. Here, the label is not a numeric value, but it's a class. For example, this is the data of some patients with uh, the information whether this person or this patient is having diabetic or not. So this is the data regarding plasma glucose, blood pressure, body mass index, and his age. And based on that, there is an outcome whether this person is diabetic or not. So based on these four parameters, we are not predicting any value, but we are predicting a class. So this is classification model. So similar to regression model, but not exactly. Here we are not predicting a numeric value, but we are predicting a class. So there are two classes. One is whether the person is diabetic, or second is the value is that person is not diabetic. So this is a two-class classification model. Now coming to unsupervised learning. As I already mentioned that in supervised learning, we have a label which has a value or a class which the machine learning algorithm will try to predict. Here we won't have anything like that. So the data does not contain any labels. So here it's obvious there is no label, so there is no column with an outcome or dependent variable. For example, if you see here, there are 5 columns, means 5 features, but none of the feature is dependent on other. They are independent of each other. So for example, this curve weight we cannot predict based on this wheelbase length, width and height. So if we try to predict, we may not get a right fit. So this is assumed that this curve weight is independent of the first 4 features, or likewise with others as well. So we just have a data and we don't have a label column whose value we are trying to predict, or whose class we are trying to identify. So this is not the case like supervised learning. We don't have a defined label here. So what will happen here? We are not predicting anything. So what we can do with unsupervised learning and this data, we can only identify some patterns in the data, that okay, this kind of data, these two data lines are similar, or this data is very different from others. So we'll try to see what are the algorithms applicable for unsupervised learning. Before we move into that, let me tell you, in machine learning, 90% of data available is suitable for unsupervised learning only. So the data is available in most of the data available in public domain will be suitable for unsupervised learning, because reason why is that supervised learning has a very clear data where you have the outcome and you have the independent variables, but in real life situation you just get the data. You will have to identify whether there is some dependent variable in the data or not. So 90% of data available is suitable for unsupervised learning. And secondly, since we are not predicting anything in unsupervised learning, the number of algorithms will be very limited. Number of tests also will be limited in this case, unlike supervised learning. So these are the two algorithms which are most primarily used for unsupervised learning. One is that clustering model. This is the which I am showing it here. So it will tell you that these are the data which are similar to each other and they can form a cluster. So they are similar to each other. They are of a particular type. So that is clustering. In anomaly detection, we just do the opposite. We will tell you that these are the data points which are very different from the normal data. So they are anomalous data. Let's try to see how this works. In the clustering model, the same example, I'm just put the same example again for that automobile data. So here you see the first two data are very similar to each other. In fact, they are exactly similar. Similarly, here the yellow one, this entire data is very similar. The three data lines or rows are very similar to each other. They are slightly different in terms of curve weight, but almost similar. So they can be classified as similar data. So this is how clustering works. So we will have some clustering algorithm in machine learning like k-means, which can identify which of the data points, the rows, you can say, are similar to each other. Now, the second thing which we can do with unsupervised learning is anomaly detection. Anomaly detection will tell you that which are the data rows which is very different from the other data. So here you see the fourth row is very different from others in terms of wheelbase, length, width. Maybe height is not that different, but crab weight is also very different. So this can be an anomalous case. So this is an anomaly detection model which we can do with unsupervised learning. So this is brief about the algorithms which we can work upon with unsupervised and supervised learning.